Welcome to Domain 1, Section 1.17, the Identify and Report phase of AI incident response. In this session, we will look at why AI incidents are uniquely hard to spot, the role of observability and baselines, and the techniques used to detect common AI-specific attacks. Why does this matter beyond the exam? You cannot respond to what you never noticed. Understanding how to detect an AI incident lets you set sensible thresholds for when a wrong answer becomes a real problem, and helps you put the right monitoring in place so threats surface early instead of after the damage is done. Let's start with what makes detection so tricky. AI is built on probability, which means it is designed to be wrong some of the time. Chasing perfect accuracy actually backfires because an overfitted model fails on new data. This creates a genuine puzzle. If some errors are normal and expected, how do you decide which wrong answer counts as an incident? Defining that threshold is what makes detecting AI threats so much harder than detecting a simple system failure. Because outputs are probabilistic, observability becomes essential, meaning the ability to see clearly into how the system is behaving. The organization needs clear metrics and a baseline of normal performance, so it can tell when a model has drifted off course. No single signal is enough, so a combination of techniques is needed. Some checks can be automated through observability tools, but others need a human in the loop to judge the subjective, borderline cases that no tool can settle on its own. It also helps to know that attacks on data are harder to catch than the data loss incidents security teams are trained on, because malicious data can be injected at many points along the pipeline. Let me give you the detection techniques for 3 common attacks. For prompt injection, where hidden instructions are smuggled into input, you sanitize and evaluate inputs and watch for unusual patterns, like text full of code-like structure or strange characters. For data poisoning, you monitor access and change logs across the data supply chain, review pre-processing scripts for unauthorized edits, and check dataset versions and their fingerprints. And for adversarial inference, where an attacker probes a model to reverse engineer it, you analyze the interface call logs and scan for the telltale patterns of systematic testing. Let's bring it all together. AI incidents are hard to identify because the system is probabilistic and some errors are by design, so the organization must define a threshold for what counts as an incident. Strong observability, clear metrics, and a normal baseline are essential, combined with both automated tools and human judgment. And each common attack, from prompt injection to data poisoning to adversarial inference, has its own targeted detection techniques. You now know how to surface an AI threat before it spirals. Every important topic and idea from this session is covered in the multiple choice questions on RooCloud.com. Before you move on to the next session, work through the chapter-wise questions there, because they sharpen exactly the instincts detection requires. Practice first, and then move forward with confidence. Thank you for watching, and I will see you in the next episode.